Okay, good morning, everyone. So, today we are going to start the next part of the Riemann theorem and factor theorem. So, in the last part, we have done the theory part of Riemann theorem and factor theorem. So, now we are going to do a small summary. Then we can go to the questions regarding the Riemann theorem and factor theorem. Okay, right. So, I will give a small summary about Riemann theorem. Right. Now, write down in that color remainder theorem. Remainder theorem. Right. Now, I will give you the definition. So we have done this definition in last week, but I will give you this definition again as a summary. Right. Now, what is the remainder theorem? Write down when any polynomial fx, when any polynomial fx is divided by x minus a, when any polynomial fx is divided by x minus a, the remainder is fa. The remainder is fa. Right. So let's see what is the meaning of that. Right. So when any polynomial fx, let's take any polynomial fx like this. Right, is divided by x minus a. Is divided by x minus a. The remainder is fa. Right. So let's take the quotient after dividing fx by x minus a as a wx. Right. Then let's take the remainder as capital R. Right. So using this, we can write down the algebraic identity. So fx will be equal to x minus a into wx, x minus a into wx plus R. Right. So same way, like this is the same method we use for the division of integers. So look at this, 9 divided by 4. If you divide 9 by 4, there are 2 4s for the 9. Right. So 4 into 2 is 8. 8 minus 9, remainder is 1. Right. So 9 is, when you divide 9 by 4, answer is 4, remainder is 1. So you can write down 9 will be equal to 4 into 2 plus 1. Right. Same thing we have done here. So if you divide fx function by x minus a, quotient is wx and remainder is capital R. So we can write down fx equal to x minus a into wx plus R. Right. Now, if you take x equal to a, if you take when x equal to a, when x equal to a, this one will become fx. This fx will become fa. Right. This fx will become fa. Then fa is equal to a minus a is 0. 0 into wx, that will become 0 plus R. So remainder R will be equal to fa. That is the remainder. So that's what we have mentioned in the theorem. Right. So when you divide any polynomial function fx by a linear factor x minus a, the remainder is fa. Right. So you can directly write down that. Okay. Now that is the summary of remainder theorem. We have done the theory part in the last class. So if you want to watch that, you can watch remainder theorem, factor theorem part 1 video. This is the part 2 video. Right. Now let's write down a small summary about factor theorem. Write down in red color factor theorem. Factor theorem. Right. So what is factor theorem? Write down in red color. When any polynomial fx, when any polynomial fx is divided by x minus a, when any polynomial fx is divided by x minus a, then x minus a, then if the remainder fa, if the remainder fa equal to 0, if the remainder fa equal to 0, then x minus a is a factor of fx. Then x minus a is a factor of fx. Right. So let's see what is the meaning of that. Right. So let's take a polynomial function fx. let's take a polynomial function fx. So when you divide this fx function by x minus a, same method like the previous one, x minus a. So the quotient or the answer is fx. Let's take the remainder as r, right? So then we can write down fx will be equal to x minus a into wx plus r, right? So when x equal to a, when x equal to a, if a will be equal to a minus a 0, this part will become 0 plus r. So r will be equal to fa, right? R will be equal to fa. So in here, if the remainder fa equal to 0, right? So they have given that fa equal to 0. If fa equal to 0, then r equal to 0. That means there is no remainder. There will be no remainder. That means you can write down this. You can write down this algebraic identity like this: fx equal to, right? Look at this. You can write down this identity fx equal to x minus a wx plus 0, because remainder will be equal to 0. Then fx, you can write down fx equal to x minus a into wx. So here there is no remainder here. Fx is directly equal to x minus a into another function. X minus a into another function. That means x minus a is a factor of fx, and also wx is a factor of fx, right? So this is a factor, and this is also a factor, because there is no remainder, right? So that is the meaning of remainder theorem. So when the remainder is equal to 0, that means we have divided this function by its factor, by one of its factors, right? I think you have understood that part. That is the summary of the previous week, right? Now let's look at this small example. Right? So I will get a small function x to the power 3 minus 2x square plus x minus 1. So we can divide this function. We can divide this function by x plus 1. Right? Now look at this. If you divide this function by x plus 1, then we can write down x to the power 3 divided by x, that is equal to x square. X square into x to the power 3. X square into 1 plus x square. Now subtract these two. X to the power 3 and x to the power 3 will be cancelled. Minus 2x square minus x square minus x square, that is minus 3x square plus x minus 1. So this is the remainder. Now you can divide this function again by x plus 1. Right? So 3x square divided by x, that is equal to minus 3x into x, that is minus 3x square. Minus 3x plus 1 into plus 1, that is minus 3x. Now divide, now subtract this. These two will cancel. X minus 3x, that is 4x minus 1. Again, you can divide 4x minus 1 by x plus 1. Then that will be equal to, if you divide 4x by x, that is 4. 4 into x, 4x. 4 into plus 1, plus 4. Now subtract these two. Then this will be equal to minus 5. Right? This will be equal to minus 5. Right. Now I can write down this function as fx. I will take this function as fx. Right. So now I can write down a summary of this function, of this division. Right. So x, I will write down here x to the power 3 minus 2x square plus x minus 1. If you divide this function by x plus 1, the remainder is x square minus 3x plus 4. This is the remainder, x square minus 3x plus 4. Right? And this is the quotient. Right? This is the answer. The remainder is minus 5. Remainder is minus 5. Right? Now, using this long division, we have write down the summary of this division. Now we can write down the algebraic identity using this division, right? So this is fx. Fx means x to the power 3 minus 2x square plus x minus 1. So this function will be equal to x plus 1 into this one plus the remainder x plus 1 into this function x square minus 3x plus 4 plus the remainder, right? So this is called an algebraic identity. This is called an algebraic identity. So we can write down this as, we can take this function as fx. We can take this function as wx. So then we can write down fx equal to x plus 1 into wx minus 5. Right? So this is the algebraic identity. We can write down this by looking at this division. Right? Okay. Now, right. Now we can find the remainder. We can find the remainder of this division by without using the long division. So we have divided this function by x plus 1 using long division. Then we have found the remainder as minus 5. Right. Now, for a moment, let's think we haven't divided this by a long division. Then we don't know the remainder, right? Then we don't know the remainder. So I will take remainder as plus r. Right? Let's assume we don't know the remainder. Right? Now we can find the remainder without using long division. That is called the remainder theorem. Right? So when x equal to minus 1, when x equal to minus 1, we can write down f minus 1 equal to minus 1 plus 1 is 0. 0 into wx is 0 plus r. Right? Then r will be equal to f minus 1. F minus 1. So we know that fx is equal to x to the power 3 minus 2x square plus x minus 1. Right? That is fx. So if you substitute minus 1 instead of x, then you can find the value of f minus 1. Right? So let's substitute minus 1 in this fx function. Then minus 1 to the power 3 minus 2 into minus 1 square plus minus 1 minus 1. Right? Then minus 1 to the power 3 is minus 1. This one is minus 2, minus 1, minus 1. So answer is minus 5. Right? R will be equal to minus 5. So you will get the same value when you divided by the long division. So this method is you can directly write down this algebraic identity by looking at the x plus 1 and fx functions. Then you can directly find the remainder without using long division. So in the next questions, we are doing that. Right. Okay. Now let's write a small question. Write down this question. I think you have understood this. We can go to a small question. Right. Write down first question. Number 1. Calculate the remainder. Calculate the remainder when 2x to the power 3 minus x square plus x minus 2. 2x to the power 3 minus x square plus x minus 2 is divided by x minus 3. X minus 3 and by x minus 1 and by x minus 1 without using long division. Right. So I will read the question again. Calculate the remainder. Calculate the remainder when 2x to the power 3 minus x square plus x minus 2 is divided by x minus 3 and x minus 1 without using long division. Right. Now let's see. They are asking us to find the value when fx. Right. When fx, so I will take this function as fx equal to 2x to the power 3 minus x square plus x minus 2. Right, I will take this function as fx. Now, when you divide fx by x minus 3, first they are asking us to find the remainder when this function divided by x minus 3. So when fx is divided by x minus 3, let's take the remainder as wx. Well, let's take the quotient as wx. Then let's take the remainder as capital R. Right? Then we can write down this identity. Fx will be equal to x minus 3 into wx plus the remainder R. Right? Now, let's take when x equal to 3. When x equal to 3, we can substitute 3. If 3 equal to 3 minus 3 is 0, so this part will become 0 plus R. Then R will be equal to F3. Now we have to find the value of F3. So you can substitute 3 in this fx function, then you can find the value of F3. Right. Okay, now I think you have understood that. So let's find the value of F3. So I'm going to substitute. So from this one we have got that remainder is equal to F3. Now I'm going to find the value of F3. So let's substitute x equal to 3. When x equal to 3, right? When x equal to 3, F3 will be equal to 3 to the power 3 minus 3 square plus 3 minus 2. Right? Then this will be equal to, right? This will be equal to we can write down 2 into we can write down this as 2 into 3 into 3 square minus 3 square plus 1. 2 minus 1. Then 3 into 2 is 6. 6 into 3 square minus this is 6 into 3 square minus 3 square means 1 into 3 square plus 1. So 6 into 3 square minus 1 into 3 square, that is 5 into 3 square plus 1. So 3 square is 9. 9 into 5 is 45 plus 1 is 46. So F3 is equal to 46. That means remainder is 46. Right? So when you divide fx function by x minus 3, right? When you divide fx function by x minus 3, the remainder is 46. Right? So in this way, we can find the remainder when this function divided by x minus 3. Right? Same way, let's find the value when fx is divided by x minus 1. Right? So look at this now. When fx is divided by x minus 1. Right? Let's take the quotient as wx and the remainder as r. Right? So then we can write down identity fx equal to x minus 1 into wx plus r. Right? So when x equal to 1, f1 will be equal to 0 plus r. That means remainder is equal to f1. Right? So we know that remainder is equal to f1. We know that fx is equal to 2x to the power 3 minus x square plus x minus 2. Right? 2x to the power 3 minus x square plus x minus 2. Now let's substitute x equal 1 here. When x equal 1, f1 will be equal to 1 to the power 3 minus 1 square plus 1 minus 2. Right? Then f1 will be equal to 2 minus 1 plus 1 minus 2. So that will be equal to 0. Right? That will be equal to 0. So that means when you divide this fx function, when you divide this fx function by x minus 1, when you divide this fx function by x minus 1, the remainder is 0. There is no remainder. Right? There is no remainder. That means this part will become 0. This part will become 0. That means x minus 1 is a factor of fx. X minus 1 is a factor of fx, and also wx is also a factor of fx. Right? Okay. Right. I think you have understood that. That is a small question. So let's go to another question. Another simple question. Right. Write down number 2. Number 2. Write down this. Let's do this question. This is a simple question. Write down. Second one. Find the remainder obtained. Find the remainder obtained when the function. Find the remainder obtained when the function 2x to the power 3 plus 3x square plus 8x minus 12. 2x to the power 3 plus 3x square plus 8x minus 12 is divided by x minus 2. X minus 2. Right? So we have to find the value. We have to find the remainder when this fx function, when this function is divided by x minus 2. Right. Now let's take this function as fx. I will take this function as fx. This is fx. Right. Now when fx is divided by x minus 2. X minus 2. Let's take the quotient as wx and the remainder as r. Right. Then fx will be equal to x minus 2 into wx plus r. Into wx plus r. Right. Into wx plus r. Right. Now let's take x equal to 2. When x equal to, f2 will be equal to 2 minus 2 is 0 plus r. Then r will be equal to f2. This will be equal to f2. Right. So we can find the value of remainder by substituting 2 in this fx function. Right. So we can find the value of f2. You have to substitute 2 here. So fx is 2x to the power 3 plus 3x square plus 8x minus 12. Now substitute plus 2 here. 2 x means, now x means you have to substitute 2 here. 2 to the power 3 plus 3 into 2 square plus 8 into 2 minus 12. Right. Now let's find the answer. 2 to the power 3 is 8 into 2 is 16 plus 2 square means 4. 4 into 2 is 12 plus 8 into 2 is 16 minus 12. Right. So this 12 and 12 cancel. 16 plus 16 is 32. So remainder is equal to 32. So when you divide this fx function by x minus 2, remainder is equal to 32. Right. So in this way we can apply this remainder theorem to simplify and find the remainder without using long division. Right. Without using long division. Okay. Right. I think you have understood that. Let's do another question. Right. Number 3. Write down next question. Number 3. Third question. Right. Write down find the remainder. Find the remainder when the polynomial function. Find the remainder when the polynomial function x to the power 5 minus 3x to the power 4 minus x square plus x plus 1. X to the power 5 minus 3x to the power 4 minus x square plus x plus 1 is divided by x square minus 7x plus 12. is divided by x square minus 7x plus 12 without using long division. Without using long division. Right. Okay. Now, let's take this function as fx. So fx is x to the power 5 minus 3x to the power 4 minus x square plus x plus 1. You have to divide this function by x square minus 7x plus 2. Right? Okay. Right. So let's take the quotient as wx. Let's take the quotient as wx. Then a remainder. So we have done in the previous week we have done that when you divide a function by another polynomial function, then the degree of this quotient will be equal to degree of this function minus degree of this function. So here degree is the maximum power. So here degree is 5. Here degree is 2. So 5 minus 2 means 3. So degree of this function, this quotient is 3. Right? And the degree of the remainder, we can find the degree of the remainder by subtracting 1 from the degree of this dividing function, right? So x square minus 7x plus 12. Degree of this function is 2. 2 minus 1 is equal to 1, right? So degree of this remainder is 1. That means this is a linear function. So we have to write down ax plus b, right? We have done that part in the previous video. So if you can't remember, please look the first video. Then we can do this question, right? So always if here degree of this function is 2, then degrees of this remainder is 2 minus 1. 1 minus the degree of this function, right? So this is the remainder ax plus b. So here we have capital A and capital B. These two are constant values. We don't know these values. We have to find these values using the remainder theorem, right? Using the remainder theorem. Okay. Now we can write down the algebraic identity, right? We can write down this one, x square minus 7x plus 12 into wx plus the remainder ax plus b. This will be equal to x to the power 5 minus 3x to the power 4 minus x square plus x plus 1, right? This is the algebraic identity. We can directly write down this identity, right? Now we don't have to find this value, find the quotient, find the value of this quotient ws. We don't need this one, right? So let's keep that one like that. Then we can we won't find the value of capital A and capital B, right? Okay. Now look at this. This is a quadratic function. You can factorize this quadratic function. So if you factorize this one will become x minus 3 into x minus 4. So x square minus 7x plus 12 is equal to x minus 3 into x minus 4. If you multiply this, you will get this. Into wx plus ax plus b will be equal to x to the power 5 minus 3x to the power 4 minus x square plus x plus 1. Right. Now, using this identity, we can find the value of a and b. Right. We can find the value of a and b. Now, look at this. So when x equal to 3. So this is the identity, right? This is the identity. So when x equal to 3, we can find the value of this. When x equal to 3, 3 minus 3 is 0. So this term will cancel. Now from here we can get 3a plus b will be equal to 3 to the power 5 minus 3 into 3 to the power 4 minus 3 square plus 3 plus 1. So 3a plus b is equal to, so if you simplify this, right? So 3 to the power 5, here 3 to the power 5. This is minus 9 plus 4, that is minus 5. I will take this one as number 1. So 3a plus b is equal to minus 5. Right? Then again, Again substitute x equal 4. When x equal to 4, substitute here. When x equal to 4, this term will become 0. Right? This term will become 0. So 0 plus 4a plus b. Right? That is equal to here 4 to the power 5 minus 3 into 4 to the power 4 minus 4 square plus 4 plus 1. Right? So 4a plus b, that will be equal to, so you can simplify this. If you simplify this, we can write down 4 to the power 5, that is 4 into 4 to the power 4 minus 3 into 4 to the power 4 minus 4 square means 16 plus 5. So this is equal to 4 to the power 4 minus 11. Right? 4 to the power 4 is 256 minus 11, that is equal to 245. 4a plus b. 4a plus b equal to 245. This is number 2. Right? So we have now two equations, two relations. 3a plus b equal to minus 5. 4a plus b equal to 245. So we can use these two as simultaneous equations. Then we can find the value of a and b. Right? Then we can find the value of a and b. Right? Okay. Right. So I will first take the second equations. Second one, this one. 4a plus b equal to 245. Then I will take the first one. 3a plus b, that is equal to minus 5. That is equal to minus 5. So let's subtract these two. Right. If you subtract these two, b and b will cancel. 4a minus 3 means a, that is equal to 245 minus 5, that is plus 5, 250. So a is equal to 250. Then we can find the value of b from number 1. From number 1, I can write down 3 times a, that is 250, plus b is equal to minus 5. Minus 5. So 250 into 3 means 750. So b is equal to minus 755. That is the value of b. Therefore, we can write down remainder r, remainder equal to ax plus b. Right? So here a means 250, x, b means minus 755. So this is the value of remainder. Right? So when you divide this fx function by x square minus 7x plus 12, the remainder is 250x minus 755. Right? Okay. So I guess you have understood that part. Okay. Right. So we have to do a lot of questions to practice this remainder theorem and factor theorem. After that, we can go to the next part of this lesson. So we are still doing small type of questions. After completing this type of question, we can do the exam questions, A-level questions regarding the remainder theorem and factor theorem. Right? Okay. Let's continue our questions. Now we have done 3 questions regarding the remainder theorem. Now let's do another question in using factor theorem. Right? So write down this question number 4. Fourth question. Write down, use the factor theorem. Use the factor theorem to separate the polynomial function. Write down, use the factor theorem to separate the polynomial function fx equal to 3x to the power 3 minus x square plus x minus 3. 3x to the power 3 minus x square plus x minus 3 into factors. Right. Now look at this. Right. So this is a polynomial function. Now we have to find the factors. We have to find the factors of this polynomial function. Right. So in previously we have saw that when right? We have so that if you divide a polynomial function fx, if you divide this polynomial function fx by a factor, now look at this. If you divide the polynomial function fx by a factor, let's say x minus a, then quotient is fx and the remainder is r, right? So we can write down fx equal to x minus a into wx plus r, right? So right, so if x minus a is a factor, right, if x minus a is a factor, then this r will become 0, right? If x minus a is a factor, then this will become 0. This is 0, right? So if this is 0, then x minus a and wx, these two are factors. These two are factors, right? So when x equal to a, if you substitute x equal to a, then if a will become a minus a is 0, if a will become 0, right? If a will become 0, right? That means if a equal to 0, that means when you divide by x minus a, the remainder is 0. That means x minus a is a factor, right? That means x minus a is a factor, right? So you can apply, you can apply reverse of this process in here, right? Reverse of this process in here. That means if you substitute any value in here, let's say for example x equal to 1. So if you substitute x equal to 1 here, if this function becomes 0 like this, if this function becomes 0, then if 1 becomes 0, then we have substituted x equal to 1, then if 1 becomes 0, then we can say that x minus 1 is a factor of this function. Same way, right? So here we have taken x equal to a. When x equal to a, if a is equal to 0, so when you take this a to the other side, x minus a, so if you divide fx by x minus a, the remainder is 0, right? That means x minus a is a factor, right? So now we are going to apply that in this function, right? So we don't know exactly when x equal to 1 or 2, what will be the value of this function, right? So if you substitute any number here, if the function becomes 0, then that is a factor, right? Then the substituted value will become a factor, right? So here we don't know what will change this function into 0. So we have to substitute different values until we get 0, right? Until we get 0. So first we can substitute minus 1, right? First we will substitute x equal to, when x equal to minus 1, we can substitute f minus 1. That is equal to 3 times minus 1 to the power 3 minus 1 square plus minus 1 minus 3, right? Then f minus 1 will be equal to minus 3, so this is minus 1 minus 3. So f minus 1 will be equal to minus 8. This is not equal to 0. That means if you take this minus 1 to the other side, x plus 1 is not a factor of fx, because the remainder is minus 8, not 0, right? So that means if you divide this fx function by x plus 1, the remainder is minus 8, not 0. That means x plus 1 is not a factor of this function, right? Is not a factor of this function, right? Now let's take another value. Let's take when x equal to 1. When x equal to 1, we can find the value of f1. f1 equal to 3 times 1 to the power 3 minus 1 square plus 1 minus 3, right? So this is equal to 3 minus 1 plus 1 minus 3 f1. These two will cancel and these two will cancel. So f1 is equal to 0, right? Now the remainder is 0, right? Now the remainder has become 0. So if you take plus 1 to the other side, x minus 1 will be equal to 0. X minus 1 will be equal to 0, right? That means when you divide this fx function by x minus 1, the remainder is 0. That means x minus 1 is a factor of fx, right? Likewise, we can find the factors by substituting different values for this fx function, right? Normally, first we substitute minus 1, then we substitute plus 1. So if we haven't got any factors, then we can substitute minus 2, then plus 2. Still, if we haven't got any factors, we can substitute minus 3 and plus 3. After that, we don't substitute any values, because up to minus 3 and plus 3 is the maximum point where you have to substitute in A levels. After that, you don't get any questions after that, right? So here x minus 1 is a factor. Here x minus 1 is a factor, right? So we know that if x minus 1 is a factor, when you divide by x minus 1, the answer is also a factor. The answer is also a factor, right? So let's divide this function by x minus 1, right? So let's take this fx function, x to the power 3, 3x to the power 3 minus x square plus x minus 3, right? Let's divide this function by x minus 1. Right? By x minus 1, then tx to the power 3 divided by x, that is 3x square. 3x square into x, 3x to the power 3, 3x square into minus 1 minus 3x square. Right? Then you can subtract these two. 3x3 minus 3x to the power 3 will cancel. Minus x square minus 3x minus 3x square. That means plus 2x square plus x minus 3. Right? Plus x minus 3. Now again divide 2x to the power 2 by x. Then it will become 2x. Multiply 2x by x. 2x square. Multiply 2x by minus 1 minus 2x. Right? So this will become plus 3x minus 3. Right? Now again divide 3x by 3. 3x by x. Then 3. 3 into x. 3x. 3 into minus 1 minus 3. 0. Right? So you can see that the remainder is 0. That means x minus 1 is a factor. So we can write down 3x to the power 3 minus x square plus x minus 3. If you divide this by x minus 1, the answer is 3x square plus 2x plus 3. Remainder is 0. Right. Now from this we can write down the algebraic identity. We can write down x. Right. We can write down this x minus 1 into on this answer 3x square plus 2x plus 3 plus the remainder is equal to this function fx 3x to the power 3 minus x square plus x minus 3. Right? Okay. Right. So let's take this function as fx. Then fx will be equal to x minus 1 into 3x square plus 2x plus 3. Right. So here we have a quadratic function. So you can factorize this function further. I will take this 3x square 2x plus 3, this function as gx. I will take this part as gx. So gx is equal to 3x square plus 2x plus 3. So you can factorize this. So before factorizing, we can find if there are any factors. So we can check the determinant delta. Right. So here delta is equal to b square minus 4ac. You know that delta is equal to b square minus 4ac. Right. So here we can find the value of delta. That means b means 2 square minus 4 into a means 3, c means 3. So delta value is equal to 4 minus 4 into 3 is 12, 36. So that means delta is a negative value. Delta is a negative value, right? So if delta is negative value, that means there are no roots. So we cannot factorize this further. We cannot factorize this further. So this is the final answer. Fx equal to x minus 1 into second factor 3x square plus 2x plus 3, right? So this is the final value of this function. We can factorize this fx function into two factors. Right? Now, I think you have understood this. Let's do another question. Right. So, write down this question. Right. Write down, factorize the polynomial function. Factorize the polynomial function. Write down, factorize the polynomial function. X to the power 4. X to the power 4 minus 5x to the power 3 minus 13x square plus 53x plus 60. Right? Factorize the polynomial function x to the power 4 minus 5x to the power 3 minus 13x square plus 53x plus 60 using the factor theorem. Right. So I will take this function as fx. Let's take this as fx. Now we can use the same method. You can substitute different values for x equal to 1, x equal to 2, x equal to minus 1 likewise. Then if you get the answer as 0, if you get the value of this function as 0, then that means it is a factor, right? Okay, right. So let's substitute x equal to 1, right? Let's substitute x equal to 1. So f1 equal to 1 to the power 4 minus 5 times 1 to the power 3 minus 13 1 square plus 53 into 1 plus 60. Right. Now f1 is equal to 1 minus 5 minus 13 plus 53 plus 60, that is equal to 96. Right. So that means the remainder is 96. That means x, if you take 1 to the other side, that means x minus 1 is not a factor because the remainder is 96. Right. Okay. So let's substitute another value. Let's take when x equal to minus 1. Let's substitute minus 1. F minus 1 equal to minus 1 to the power 4 minus 5 times minus 1 to the power 3 minus 13 minus 1 square plus 53 minus 1 plus 60. Right. So if minus 1 equal to 1 minus plus 5 minus 13 minus 53 plus 60. Right. So if you simplify this, 1 plus 5 66 minus 13 minus 53 minus 66. So this will become 0. F minus 1 is equal to 0. F minus 1 will be equal to 0. That means when you divide by x plus 1, when you divide fx function by x plus 1, the remainder is 0. That means x plus 1 is a factor, right? X plus 1 is a factor of this function, right? That means we can divide this function by x plus 1, then the answer is also a factor. So let's divide this fx function by x plus 1, and let's find the other factors. Okay. Now look at this. Right. So we can divide this function. Right. We can divide x to the power 4 minus 5x to the power 3 minus 13x square plus 53x plus 60. X to the power 4 minus 5x square minus 13x square plus 53x plus 60 by x plus 1, because x plus 1 is a factor. X plus 1, right? Okay. Now let's find the answer. So if you divide by x to the power divide by x, that means x to the power 3, x to the power 3 into x to the power 4, x to the power 3 into plus 1 plus x to the power 3. Subtract these two will cancel. Minus 6x to the power 3, right? Minus 6x to the power 3. Then take this remaining part, minus 13x square plus 53x plus 60. Divide minus 6x to the power 3 by x, that means minus 6x square multiplied by x minus 6x to the power 3 multiplied by plus 1 minus 6x square. Again subtract these two. Minus 6x to the power 3 and minus 6x to the power 3 will cancel. Minus 13x square minus 6x square, that is equal to minus 7x square plus 53x plus 60. Right. Now again we can divide by x. Minus 7x multiplied by x minus 7x square multiplied by plus 1 minus 7x. Again subtract, these two will cancel. 53x minus 7x, that means 60x plus 60. Now again divide by x. If you divide 60x by x, then plus 60 multiplied by x, 60x multiplied by plus 1 plus 60. Then these two will cancel. Answer is 0. Right. So now you see that the remainder will become 0. That means x plus 1 is a factor. And also this quotient is also a factor. This quotient is also a factor. Right. Okay. Right. Then by looking at this, we can write down the identity. Right. So I will write down x plus 1 into this quotient x to the power 3 minus 6x square minus 7x plus 60. Right. Plus 60 plus the remainder 0. 0, that is equal to x to the power 4 minus 5x to the power 3 minus 13x square plus 53x plus 60. Right. Okay. Now right. So this is the function fx. Let's rewrite this. So I will take this function as fx. I will take this one as fx. This is fx. Right. Then I will take this function as gx. This is gx. This function as gx. Right. Therefore, we can write down fx equal to x plus 1 into gx. Now, if you look at this, gx is a third degree polynomial function. Gx is a third degree polynomial function. Right. So we can separate gx into factors. Right. Here gx is a third degree polynomial function. I will separately write down gx equal to x to the power 3 minus 6x square minus 7x plus 60. Now there are two factors, mainly two factors, fx equal to x plus 1 into gx. Gx is a third degree polynomial. Again, we can factorize gx into factors. Then we can find the other factors. Right. So we have applied factor theorem and separated and found two factors. Now again apply factor theorem and separate this function into factors. Right. Again apply factor theorem. Right. So here also we can find the values when x equal to 1, minus 1, plus 1, plus 2, minus 2. Right. So when x equal to 1. Right? Let's find value when x equal to 1. So when x equal to 1, g1 will equal to g1 will be equal to 1 to the power 3 is 1 minus 1 square 6 minus 7 plus 60. Right? So g1 will be equal to 48. So this is not equal to 0. That means x minus 1 is not a factor. This is not equal to 0. Right? Now let's take x equal to minus 1. X equal to minus 1. So g minus 1. So if you substitute minus 1 to the power 3 is minus 1. Minus 1 square means plus 1. That means minus 6 plus 7 plus 60. So this is equal to 60. And this is also not equal to 0. It is also not equal to 0. So x here x minus 1 is not a factor. X plus 1 is also not a factor. Same way we can substitute x equal to minus 2. That means g minus 2, that is equal to minus 8. Minus 8 minus 2 square means 4. 4 into 6 means minus 24. 7 into 2 means minus 14 plus 60. That is equal to 42. That is also not equal to 0. Then let's substitute x equal to plus 2. Right? Then g plus 2. So if you substitute plus 2, then that is equal to 8 minus 24 minus 14 and plus 60. So here answer is 24. That is also not equal to 0. Right? So I have substituted x equal to 1, minus 1, minus 2, plus 2. So the answer is not equal to 0. That means remainder is here, remainder is 40, 60, 42, 24. So all of these are not factors. These are not factors, right? Now I will substitute x equal to minus 3, right? X equal to minus 3. Then g minus 3. I can write down as minus 3 to the power 3. That means minus 27. Minus 3 square into minus 6. That is equal to minus 54. Minus 3 into minus 7. That is plus 21 plus 60. So these 4 will cancel, right? These things will cancel. So answer is 0, right? That means this is a factor, right? So you have to substitute until you will get a factor, right? So now it's equal to minus. When you substitute x equal to minus 3, the remainder is equal to 0. That means x plus 3. X plus 3 is a factor. X plus 3 is a factor, right? Okay. Now we can write down x plus 3 is a factor of gx. X plus 3 is a factor of gx. That means we can divide gx function by x plus 3. We can divide gx function by x plus 3. Then we can find the other two factors. Right? So let's divide gx function. Gx means x to the power 3. X to the power 3 minus 6x square minus 7x plus 60. Divide this function by x plus 3. Then you will get the quotient. From that we can find the other two factors. So if you divide by x square into x to the power 3, x square into plus 3 plus 3x square. Subtract these two, minus 9x square minus 7x plus 60. Right? Divide 9x square by x minus 9x square minus 9 plus 3 minus 27x. So again subtract these two will cancel. Plus 20x plus 60. Divide by x plus 20. 20 into x, 20x. 20 into 3 plus 60. So these two will cancel. Answer is remainder is 0. That means x plus 3 is a factor of gx. X plus 3 is a factor of gx. Right? So I can write down x, but gx means x to the power 3 minus 6x square minus 7x plus 60. This is equal to x plus 3 into the quotient x square minus 9x plus 20 plus remainder is 0. Remainder is 0. Right? So this is gx. This function is gx. Right? So we have found the factors of gx. We have found the factors of gx. Right? So I will write down gx function. Now look at this. Gx equal to x plus 3. X plus 3 into x square minus 9x plus 20. Right? These are the two factors of gx function. Now this is a quadratic equation, x square minus 9x plus 20. This is a quadratic factor. Again, you can separate this factor into two factors. Right? You can separate this factor into two factors. So if you separate that, we can write down gx will be equal to x plus 3 into this one. We can separate into two factors, x minus 4 and x minus 5. So if you multiply, you will get x square minus 5x minus 5x minus 9x plus 20. Right. Okay. Now look at this. Now we know that fx is equal to fx is equal to x plus 1 into gx. Right? We have got that answer in the previous step. Now we can write down all the factors of fx function. Fx equal to x plus 1 into gx means x plus 3, x minus 4, x minus 5. So these are the factors of fx function. Right? So this is the method of factorizing a polynomial function using the factor theorem. Right? Using the factor theorem. So you can use this method to factorize any polynomial function. Right? Okay. Right. So I think you have understood that question. Okay. Now let's go to the next part. Next question.